Every single year, more than 170 million old refrigerators are disposed of throughout the world. However, what actually happens to them once they disappear from our kitchens? Refrigerants that can damage the ozone layer, hundreds of pounds of metal, plastic, and even precious metals all require specialized processing. Did you know that old refrigerators contain gold, silver, and copper that can all be given a second life? And some models are even sold to poorer countries instead of being recycled. Please stay with us to see how junk is turned into a resource and discover who is making millions of dollars in the process. In the United States of America, there are several ways old refrigerators are collected for disposal, ensuring safe and environmentally responsible recycling. Some large retail chains, such as Best Buy, offer programs to recycle old household appliances. When you purchase a new refrigerator, they can take the old one away for further recycling. These programs often come with restrictions, for example, no more than 3 appliances per day from a single household. There are a few reasons for limits on how many appliances can be recycled. The first reason is logistics and the burden on the system, since recycling centers have limited capacity. If everyone could drop off any number of appliances, the collection and recycling processes could become overloaded. These programs are also intended for individual consumers, not for businesses or resellers. The limits also prevent hauling companies from making free use of disposal services. The third reason concerns cost optimization. In many cases, recycling is subsidized by the government or by private companies. The restrictions help control expenses and distribute resources evenly. The final reason is environmental responsibility. These programs often encourage people to switch to energy-efficient devices rather than simply throwing away large quantities of appliances. It is a kind of balance between convenience for consumers and the operational efficiency of the recycling centers. In many cities and districts, there are municipal collection points for large household appliances. Consumers can bring their old refrigerators to these points, where specialized companies pick them up for recycling. These collection points can be stationary or mobile, which makes it more convenient for residents. Some energy companies also offer programs for disposing of old, inefficient refrigerators. They may provide financial incentives or free appliance removal to encourage consumers to switch to energy-saving models. There are also private companies that specialize in collecting and recycling large household appliances. They offer services to remove old refrigerators directly from the consumer's home for a certain fee. These methods of collecting old refrigerators support the responsible handling of electronic waste, ensuring proper recycling and minimizing negative impacts on the environment. After collection, old refrigerators are taken to specialized recycling centers, where they are sorted and prepared for disposal. This process unfolds in several main ways, which we will describe right now. Many major cities have specialized facilities that accept old appliances directly. For instance, in the United States of America, such facilities operate under programs focused on the responsible recycling of electronics. In some situations, refrigerators are first sent to warehouses or designated lots where enough units are accumulated for subsequent mass recycling. This saves on transportation costs and streamlines logistics. Some large brands, such as Whirlpool or LG, run their own recycling programs. They take back old refrigerators, break them down, and reuse some of the materials in the production of new appliances. Sometimes, old but still functioning refrigerators are sold or transferred to less developed countries. This practice is considered controversial because such equipment can consume a lot of energy and may contain hazardous substances. How do you feel about this issue? Is it better to have a refrigerator that poses potential harm, or is health more important than questionable humanitarian aid? In Europe, there are strict regulations regarding the recycling of household appliances. For instance, under the Waste Electrical and Electronic Equipment Program, refrigerators are transported to certified centers, where they are taken apart into environmentally safe components. At every stage of this process, safety regulations must be observed, because refrigerators contain refrigerants and other potentially harmful substances that cannot simply be dumped in a landfill. Before a refrigerator is sent for dismantling, Its technical condition is assessed. Models that still work can be repaired and resold or donated to charitable organizations. Faulty or obsolete models are immediately directed to further processing. Next, refrigerators are categorized, since different models contain different materials and refrigerants. They are divided into industrial refrigerators, household refrigerators, and refrigerators containing harmful freon. After that, refrigerators are checked for the presence of hazardous gases and liquids. Freon and other refrigerants are removed because they require special disposal methods as they deplete the ozone layer. Lubricants are drained since they can contain heavy metals. Before extracting freon, technicians place the refrigerator in a designated treatment area where they check which specific refrigerant is used. Technicians connect the refrigerator to a vacuum pump, which creates pressure inside the system and forces the freon to flow in the required direction. The refrigerant is drawn out through specialized valves, after which the gaseous freon is collected in sealed containers, while the liquid freon is filtered and can either be used again or sent for chemical recycling. The freon that is collected undergoes purification to remove oil, moisture, and metal particles. After that, it is either destroyed or reused in cooling equipment. Older banned refrigerants must not be released into the atmosphere, so they are incinerated in special high-temperature installations that break them down into harmless components, or they are converted into newer, safer gases through chemical reactions. All of this happens at certified facilities because mishandling freon can cause damage to the environment. Once the freon and other refrigerants have been dealt with, it is necessary to drain the lubricants from the refrigerator. These fluids contain pollutants that can harm the environment. The lubricant in a refrigerator is mostly in the compressor, which is responsible for circulating the refrigerant. During operation, it mixes with freon, so removing both substances often occurs simultaneously, although it depends on the specific model. Before draining the lubricant, the compressor is removed or punctured so that the fluid can flow out freely. The lubricant then either drains by gravity into a collection tank, or it is pumped out by a vacuum device. Special containers are used to prevent spills and the evaporation of dangerous substances. The collected fluid is then purified of any remaining freon, metal particles, and other impurities through settling and filtration. After purification, the lubricant can be reused in compressors if additional cleaning is performed. If it cannot be recycled, it is incinerated in special furnaces. It can also be applied in certain industries, for instance, in the production of technical lubricants. This is carried out at specialized facilities to prevent leaks of harmful substances into the environment. Modern refrigerators contain electronic boards, displays, and battery elements. Workers remove these parts by hand because automated conveyors cannot handle such components without damaging valuable materials. Prior to shredding, refrigerators undergo inspection. Wiring, plastic parts, and insulating panels are taken off. These materials are sorted for further recycling or safe disposal. In general, human oversight is required at every step to ensure safe and clean disassembly. However, certain processes are automated. For example, shredding metal housings or compressing plastics. The external body of a refrigerator is usually made of steel or aluminum sheet. It is separated either by hand or by hydraulic machines and sent for shredding. Compressors and condensers have a high content of non-ferrous metals, such as copper and aluminum, so they are taken apart separately. Copper and aluminum are then sent for smelting and used in new electric devices. Refrigerators also contain many plastic parts, such as internal panels, shelves, bins, and door gaskets. Workers remove these elements by hand because the plastic must be sorted by type. Certain types of plastic are recycled into pellets, which are later used to manufacture new products. Some refrigerator models feature glass shelves or glass doors in display-style refrigerators. This glass is removed manually, sorted by quality, and sent for remelting. Modern refrigerators include control boards, displays, wiring, and batteries. Electronic parts are taken out and transferred to specialized facilities for extracting precious metals like gold, silver, and palladium. Most refrigerators have foam polyurethane or polystyrene foam as insulation. It is removed or shredded and some of that material can be used as filler in construction or for manufacturing new insulation. Metals go to metallurgical plants. Plastics are compressed into briquettes and sent to recycling facilities. First, the plastic parts, meaning bins, shelves, and outer components, are placed into special shredders. Inside these machines, blades or rotary cutters chop the plastic into tiny pieces no more than 2 inches in size. Next, the plastic fragments are washed in water baths to remove dust, adhesive residue, labels, and other impurities. Some plastics undergo separation, during which they are divided by density. For example, lighter polymers float to the surface, while heavier ones sink to the bottom. The cleaned plastic is sent through powerful drying units to ensure it has no excess moisture, since moisture can reduce the quality of the recycling process. The dried plastic is then fed into hydraulic or mechanical presses, where it is compacted under pressures of up to a few hundred short tons. This process occurs without heating, so the material does not melt but simply becomes more dense. The pressed plastic is formed into briquettes weighing from a few pounds to a few dozen pounds, depending on what clients need. The finished briquettes are wrapped in film or secured with metal straps so that they do not fall apart during transport. They are then shipped to factories where the plastic will be melted and converted into new items such as plastic containers, furniture, pipes, or even parts for new refrigerators. This method conserves space during transport and reduces logistics costs, since pressed plastic occupies several times less volume than loose fragments. Glass is remelted and used in new glass products. Electronic parts are recycled separately, and precious metals are extracted from them. Insulation materials are partly disposed of or reused. Thanks to modern technology, most materials from old refrigerators get a second chance at life. Every year, more than 12 million cars are scrapped worldwide, and this has become a massive industry running like clockwork. Imagine this. Your old ride could turn into a brand new skyscraper, and that worn-out engine might end up in a military battleship. But what actually happens to cars that have reached the end of the road? They are not simply tossed away. 90% of their materials get recycled. How are cars dismantled, crushed, and literally torn apart to be turned into something new? Today, we are taking a deep dive into this process. Why can you not just leave your old car sitting in the backyard? Well, first of all, it is illegal. Unless you live somewhere where keeping a car on bricks in your yard is completely fine. Second, old cars leak fluids, motor oil, antifreeze, transmission fluid, that can seriously damage the environment. Third, they take up space that could be used for something better, like a new car or even a barbecue grill. So, what are your options? If your car is still somewhat functional, you can sell it for parts. Even if the engine is done for, many components still have value. The battery, if it is still working, can be sold separately or taken to a recycling center. Tires, if the tread is still decent, can be resold. The catalytic converter contains precious metals like platinum, palladium, and rhodium, making it highly valuable. Headlights, mirrors, doors, there is always someone looking for replacement parts. You can sell them on Facebook Marketplace, Craigslist, or local auto shops that buy used parts. If your car is so far gone that even a tow truck refuses to take it, scrapping it for metal is the way to go. On average, scrap metal prices range from $100 to $300 per 2,000 pounds, meaning a regular sedan could get you anywhere from $200 to $600. Before dropping it off, make sure you have the proper paperwork, remove all personal belongings from the interior, and if possible, drain the fluids. Many scrapyards will pick up the car themselves, especially if it is undrivable. How about donating it to charity? In the United States, plenty of organizations accept cars as donations, even if they are not running. Some examples include Cars for Kids, Goodwill car donations, and Wheels for Wishes. You just make a call, they tow it away, and you get a tax deduction. Plus, it feels good knowing your old clunker is helping someone in need. From time to time, government programs allow you to trade in an old vehicle for compensation. In California, for instance, the Consumer Assistance Program offers up to $1,500 for cars that fail to meet environmental standards. It is worth checking if similar programs exist in your state because this might be the most profitable option. Do not leave your car abandoned on the street. That could result in fines or impoundment. Do not try to dismantle it yourself unless you know what you are doing. Some parts, like the fuel tank or battery, can be hazardous. And do not confuse proper recycling with illegal sales. Many states have strict regulations about selling non-operational vehicles without the right documentation. The key is doing it correctly to avoid trouble and protect the environment. In movies, we often see massive junkyards filled with rusting cars under the scorching sun. In reality, most vehicles do not just sit there. Modern recycling is a well-organized process where nearly 90% of materials get repurposed. If a car is beyond repair, it moves on to the dismantling stage. You already know about the initial teardown. After that, the car goes into a hydraulic press, the same machine you have probably seen in movies. It compresses the car into a compact cube, reducing its size by several times. These crushed cars are then sent to massive industrial shredders, huge machines that literally rip the car apart. After that, the shredded metal and plastic move on to sorting. Sorting is done using magnetic separators, which separate metals. Steel and iron are the easiest to extract since they are attracted to magnets. Aluminum, copper, and brass are removed using eddy currents and other techniques. Plastics, glass, and rubber are collected separately, although not everything can be recycled. Once sorted, the materials go to specialized recycling plants. Steel and aluminum are melted down and used to manufacture new cars, construction materials, household appliances, and more. Wheel rims and engine blocks are often turned into new auto parts. Components like bumpers, dashboards, and interior panels are shredded and reused for making furniture, insulation, or even new cars. Automotive glass contains a plastic layer inside, making it harder to recycle, but some companies repurpose it into construction materials. Tires do not decompose and are an environmental hazard, so they are repurposed as much as possible. They are turned into asphalt granules, rubber flooring for playgrounds, and even fuel for cement plants. 99% of car batteries are recycled. The lead is melted down, and the acid is either neutralized or reused. Despite all these processes, about 10 to 20% of car waste remains non-recyclable. This includes certain plastics, adhesive materials in upholstery, and textile or leather interior elements. Researchers are working on new disposal methods, such as pyrolysis, breaking materials down at high temperatures without oxygen, or using biodegradable materials for future vehicles. Today, around 12 million cars are recycled in the United States every year, making it one of the most advanced recycling industries. But back when cars first started taking over the roads, nobody really thought about what to do with them once they stopped working. Picture the early 20th century. Ford releases the legendary Model T. Cars become affordable to the masses, but what happens when they break down? In the early 1900s, old cars were often just left on the roadside or dumped in forests. Many were abandoned in backyards, slowly swallowed by weeds. Some cities even tossed them into rivers or burned them, simply because there was no system in place. Over time, scrapyards emerged, where enterprising individuals collected metal from wrecked cars, melted it down, and repurposed it. By the 1920s and 30s, metal was in high demand for construction, turning old cars into valuable resources. During World War II, the United States and Europe faced an enormous need for steel and other metals. Suddenly, junk cars became a gold mine. Governments even encouraged citizens to turn in their abandoned vehicles for scrap to produce tanks, weapons, and military equipment. By the end of the war, car recycling had become a structured industry, and businesses started opening specialized vehicle recycling plants. In the 1950s and 60s, cars became more affordable. People bought them in droves and just as quickly discarded old models. Huge car graveyards emerged, where vehicles simply rusted away, taking up massive amounts of space. Soon, environmentalists raised concerns: oil leaks, gasoline spills, lead contamination. Gasoline still contained lead back then. and other toxins were polluting the land and water. This pushed governments worldwide to implement stricter recycling regulations. By the 1970s, the first serious car recycling programs were introduced. Since the 1980s, vehicle recycling has become more systematized. Companies started using automated shredders to rapidly dismantle cars. Today, modern cars are about 80% recyclable, but manufacturers are working to push that number up by another 10%. In Japan and Europe, laws require automakers to take back their old models for recycling, encouraging the production of more eco-friendly vehicles. Recycling metal from old cars saves up to 74% of the energy compared to producing new metal. Some countries have extremely strict environmental standards: Germany, Switzerland, and Japan. In these places, before cars are crushed, they are burned in specialized facilities to remove plastic residues and other combustible materials. Sounds interesting? Absolutely. This process, called pyrolysis, happens in industrial furnaces designed for thermal decomposition. Once the vehicle fluids are drained and key components are removed, the car is placed in a high-temperature chamber. The temperature inside ranges from 800 to 1,200 degrees Fahrenheit. Materials break down without oxygen, causing plastics, adhesives, textiles, and other organic materials to evaporate, leaving behind only the metal frame. The gaseous byproducts go through advanced filtration systems to capture heavy metals and toxic compounds. The result: minimal emissions and a cleaned-out metal shell, ready for crushing or smelting. Imagine this. Every single year, all around the world, over 70 million automobiles are manufactured, and each one of them demands high-technology glass. From the broken flask with nitrocellulose that accidentally revealed laminated glass, to the powerful hydrophobic coatings, the history of this material is truly astonishing. Today, we are going to learn how glass becomes ultra-strong, safe, and prepared to protect us from wind, rain, and the dangers of the road. Please get ready for a journey into the realm of advanced modern technology. Thousands of short tons of glass scrap are recycled in order to create crystal-clear windows for automobiles. It is not only about safety, but also about saving precious resources. And that is just the beginning. The history of automobile glass production is closely linked to the development of the automobile industry, which emerged in the late 19th century. The glass used in today's automobiles has undergone a long path of improvements that have made it safer, stronger, and more functional. When the very first automobiles began to appear, they were initially not equipped with any glass at all. The open body design offered only partial protection to passengers, while dust, wind, insects, and other hazards made traveling extremely uncomfortable. Later on, when automobiles became faster, the need for driver and passenger protection emerged. Windshields were first made from ordinary window glass, which, although it provided some degree of protection, had a serious drawback. In accidents, it would shatter into large, sharp fragments that resulted in numerous injuries. The first groundbreaking discovery in the field of automobile glass was the creation of laminated glass. This happened by chance. In 1903, a French chemist named Edouard Benedictus accidentally dropped a flask coated with nitrocellulose. The glass cracked but stayed in one piece, thanks to the thin layer of plastic. This accident inspired the scientist to develop a multi-layered glass, which later became the basis for triplex. By the 1910s, laminated glass was already being used in premium class automobiles. Its construction consisted of 2 layers of glass with a thin, transparent film in between them. In the event of impact, the glass did not scatter, and cracks remained on the film. In the 1920s, laminated glass began to be widely used in the production of windshields. Its main advantage was increased safety. Even in serious accidents, the fragments did not fly apart, but remained embedded in the polymer layer. The next stage in the evolution of automobile glass arrived in the 1930s, when the technology for making tempered glass was patented. This material was produced by heating the glass to high temperatures followed by a rapid cooling. As a result of such a process, the glass became stronger, and upon breaking, it would fracture into small pieces with dull edges, minimizing injuries. By the middle of the 20th century, tempered glass was being used for the side and rear windows of automobiles. It was less expensive to manufacture compared to triplex and provided a sufficient level of safety for those parts of the vehicle. In the 1950s and 1960s, automobile glass became even more advanced thanks to ongoing technological progress. During this time, several important changes took place. Improvement of triplex. The development of new polymer films made laminated glass more transparent, resistant to ultraviolet radiation, and more durable. Mass production. The automation of manufacturing processes drove down the cost of automobile glass, making it more affordable for a wide range of consumers. Coatings for sun protection. Special coatings that blocked ultraviolet rays and reduced the heating of the automobile cabin were used for the first time. One of the most significant technological breakthroughs in glass production was the invention of the float method in 1959. This technology, developed by the British company Pilkington, enabled the manufacturing of perfectly smooth glass by allowing molten glass to spread across the surface of molten tin. Through this method, the glass became more uniform, stronger, and better suited to mass production. Even today, the float method remains the foundation of automobile glass manufacturing, ensuring precise dimensions, a smooth surface, and high quality. In the second half of the 20th century, automobile glass underwent even more changes aimed at improving both safety and comfort. In the 1960s, heating filaments began to be installed in the rear window of automobiles, preventing condensation and freezing. In the 1980s, glass was introduced with special metallic coatings that reflected sunlight and reduced heat buildup inside the vehicle. Glass with ultraviolet protection. With the introduction of new technologies, automobile glass began providing virtually complete protection from harmful ultraviolet radiation. And now, we enter the modern period of automobile glass production, which we will discuss at this very moment. We shall start with the glass used in automobiles. Automobile glass is divided into several types, depending on its purpose and manufacturing technology. Windshield. This is usually multi-layered glass composed of two sheets of glass with a polymer film between them. This design ensures that, if damaged, the glass does not break into sharp fragments. Side and rear glass. Most often, this is tempered glass, which, upon impact, fractures into small, blunt-edged pieces that reduce the risk of injury. Panoramic roofs, or other special types of glass, often use laminated or tempered glass with specialized coatings for protection against ultraviolet radiation. The main components of glass are natural materials, which are mixed in certain proportions to achieve the desired properties. Quartz sand is the principal element in glass, giving it transparency. It must be extremely pure and contain minimal impurities. Soda is added to lower the melting temperature of glass. Lime improves the mechanical durability and chemical characteristics of glass. Additional additives. These are used to adjust color, transparency, resistance to ultraviolet light, and other properties. The raw materials are cleaned, dried, and ground to a uniform state. It is crucial to eliminate as many impurities as possible, as they can affect the quality of the glass. After preparation, the raw mixture is poured into special furnaces for melting. This stage includes a few important steps, so let us review them together. Melting temperature. To create molten glass, a temperature of about 2,732 degrees Fahrenheit is used. Throughout the melting process, the raw materials transform into a uniform, viscous liquid. Homogenization. The molten glass is stirred to distribute components evenly. This is important for preventing air bubbles or other irregularities in the finished product. The furnaces for melting glass are equipped with modern systems for temperature control and process automation, which guarantee the high quality of the final product. After melting, the molten glass proceeds to the forming stage, most commonly performed using the float method in modern manufacturing. Feeding the molten glass. The liquid glass flows from the furnace onto a bath of molten tin. Due to the high density of tin, the molten glass spreads out uniformly across its surface. Under its own weight, the glass forms a perfectly even and smooth surface. Gradually lowering the temperature makes the glass grow solid. By the time it leaves the tin bath, it is ready for further processing. The float method allows the production of glass sheets with precise geometric parameters and a very high-quality finish. Once it is cooled, the sheets of glass are cut to the sizes required for automobile manufacturing. Automated cutting machines ensure accuracy, and to prevent chips or cracks, the edges of the glass are polished. Every sheet is checked for defects, such as microcracks, bubbles, or other damage. Next, to ensure the strength and safety of automobile glass, it undergoes the process of tempering. The glass is heated to a temperature of around 1,112 degrees Fahrenheit. Then the surface is quickly cooled by air jets, while the inner layers cool more slowly. As a result, stress is created, which greatly increases impact resistance. Tempered glass, when broken, shatters into small, safer fragments, minimizing the risk of injuries. After that, for the windshield, a triplex construction is used, which is a combination of glass and polymer film. Its fabrication involves several steps. Layer bonding. A polymer film is placed between two sheets of glass. The construction is placed into a vacuum press to remove air bubbles. Then the glass is heated in an autoclave to 284 degrees Fahrenheit under high pressure, ensuring a strong bond between the layers. Triplex has high impact resistance, and if damaged, the fragments stay attached to the polymer film, thus providing safety for the driver and passengers. Afterward, to enhance the properties of automobile glass, various coatings are applied. Anti-glare coatings reduce glare from the sun or from other vehicles' headlights. Ultraviolet protection. Special layers block harmful ultraviolet radiation. Hydrophobic coatings allow water to bead and roll off the glass surface. Heating elements. Thin heating filaments can be embedded in the windshield, making it easier to remove ice or condensation. To achieve the required shape, special thermoforming equipment is employed. The glass is heated to a temperature at which it becomes pliable, and it is then molded according to specified parameters. And here we arrive at the final stage. During this stage, each piece undergoes a thorough inspection. The transparency is tested, and any defects are identified. Next, the glass is tested for impact resistance and durability under load, compliance with standards, the accuracy of dimensions, the shape, and other parameters are verified. Then the finished automobile glass is packaged in a manner that prevents damage during transportation. It is delivered to automobile factories or service centers, where it is installed in vehicles. The production of automobile glass is a high-technology process that brings together physics, chemistry, and engineering. Thanks to advanced technologies and strict quality control standards, automobile glass ensures safety, comfort, and longevity. And just imagine how many stages automobile glass must go through so that we can watch over road safety and admire wonderful vistas along the way. I find it remarkable. Do you also think so? Every single day, more than 20 million banknotes are destroyed in the United States. That is a mountain of money that could reach the sky. But what exactly happens to them? Are they burned, shredded, or maybe turned into something completely unexpected? US dollars have their own life cycle, and their disposal is a high-security operation involving armored trucks, strict inspections, and secret routes. How do old banknotes disappear forever? And is there any way to save them? Let's find out. The dollar as a currency has a fascinating history. It all began in the mid-17th century. The first dollars appeared in the New England colonies in the year 1690, at a time when the United States did not yet have a unified national currency. Back then, the colonies issued their own money, and one of these was the so-called paper dollar. However, the true dollar as we know it today emerged later, in the year 1792, when the United States Congress passed the Coinage Act. This was the country's first attempt to introduce a single currency, establishing the dollar standard based on a silver coin. The dollar quickly became the main currency for trade and wealth accumulation, as the nation sought to create a stable and accessible monetary system that would support its economy and commercial ties. Today, the dollar has evolved into one of the world's leading currencies, used in international transactions across the globe. The idea of disposing of old banknotes arose at the beginning of modern financial systems, especially when currencies started to become standardized and central banks began managing the money supply. In other words, the process of removing worn-out dollars started as soon as money became a stable and regulated instrument, though it was not officially systematized until much later. The concept of destroying damaged money first appeared in Great Britain during the 19th century, when the British government realized that allowing worn-out banknotes or coins to remain in circulation reduced the overall value of the currency. However, the systematic destruction of money, as it is done today, only became possible with advancements in modern financial systems and technology. In the United States, the first efforts to manage old and worn-out dollars began in the mid-19th century, when the first central authorities responsible for currency emerged, and money became a key instrument of the national economy. In the year 1861, when the United States first introduced federal paper money, known as greenbacks, the need arose to organize their circulation, including their disposal. The official process of destroying old dollars was established by the Federal Reserve after its creation in the year 1913. The Federal Reserve became the primary institution responsible for regulating the money supply, including removing old banknotes from circulation. The idea of destroying old banknotes was first introduced by central banks, which discovered that worn-out and damaged money not only harmed the image of a national currency, but could also create economic problems. If old banknotes remained in circulation, it could destabilize the monetary system, increase the risk of counterfeiting, and even affect inflation rates. To prevent this, the Federal Reserve established a clear policy outlining when and how banknotes should be removed from circulation. This became an essential part of maintaining economic stability. So, what exactly happens to all the money that can no longer be used and that no one wants to see anymore? Are they just burned? Well, not exactly. Disposing of US dollars is a complex process that follows a highly regulated system, ensuring both destruction and security. Here's how it works. First of all, when money is removed from circulation, whether it is declared damaged or obsolete, it does not simply get thrown in the trash. Everything goes through the United States Federal Reserve System, which manages the issuance and renewal of dollars. They collect old banknotes and send them to specialized facilities for further disposal. When you or someone else brings damaged or worn-out dollars to a bank, that is where the process begins. Banks have strict procedures for identifying banknotes that are no longer fit for circulation. These banknotes are inspected both manually and automatically using specialized machines that detect damage, wear, or counterfeit signs. Modern ATMs and cash dispensers are also equipped with sensors to detect worn-out banknotes. If a bill is found to be damaged or degraded, it is usually placed into special compartments or sent to sorting machines in banks. Once a sufficient number of old banknotes accumulate in banks, they are sent to the next stage, the Federal Reserve. These are special facilities located across the country that inspect, replace, and dispose of currency. Several such centers exist across the United States, strategically positioned to efficiently serve all regions. The process of transporting old banknotes to the Federal Reserve or specialized disposal facilities is strictly regulated. Banks typically work with security firms specializing in transporting large sums of money. Old banknotes are packed into special bags or containers that are sealed and secured against unauthorized access. This is crucial because even old money remains a potential target for theft or counterfeiting if not handled properly. Security guards or specialized couriers deliver these packages to the Federal Reserve or disposal facilities. The transport companies involved in this process operate under the highest security standards, and shipments are often escorted by police or other security services when necessary. You would not believe how many old banknotes accumulate each year, and this applies not only to US dollars, but also to other currencies. Bank vaults are not limitless in space, so from time to time, large batches of worn-out bills must be removed. Every day, thousands of banknotes pass through people's hands. Some get crumpled, some get coffee spilled on them, and some even end up in the laundry. Add the natural wear and tear, and you have a massive pile of money that is no longer usable. Imagine this. Every single day, the United States Federal Reserve destroys millions of banknotes. If you stacked them up, they would reach as high as a skyscraper. And that is just in one day. Transporting such massive amounts requires trucks. Money is packed into special bags or boxes. Each container has a unique number and seal to ensure it remains unopened. And while these may no longer be real money in a traditional sense, they still hold value. So the security of such shipments is incredibly tight. It is almost like a scene from an action movie. Armored trucks, armed guards, secret routes. Except here, instead of a heist, the mission is to get rid of this money forever. A true financial thriller, right? Before the old banknotes are destroyed, they go through careful inspection. Special systems determine whether they can be reused. If a banknote still retains at least 50% of its original form, it can be reintroduced into circulation after a special treatment, such as reprocessing or trimming. This significantly reduces the cost of printing new banknotes. Every year, an enormous amount of old dollars is destroyed in the United States. For example, in the year 2020, around 7 billion banknotes were eliminated because they were too worn out to remain in circulation. This process is continuously maintained at the highest level to keep the currency stable. Some damaged banknotes are not immediately burned. Instead, they are recycled into other materials, such as fibers that are later used to produce new banknotes. This helps reduce production costs and support sustainability efforts. There is also an interesting psychological aspect to this process. For many people, destroying money might seem like a loss of value, but in reality, it is part of a continuous cycle that helps preserve the stability and worth of the currency. That is why this process is just as crucial as printing new money. Old US dollars are often destroyed in specialized incinerators or through processes that ensure maximum material utilization. Banknotes are burned at temperatures of approximately 2,000 degrees Fahrenheit, completely obliterating them. Furthermore, advanced filtration and technology capture toxic gases and other harmful byproducts to ensure safety during the process. But does it not feel strange to burn so much money? Given how much we spend daily, these sums seem enormous. However, the portion of money that gets destroyed is actually a tiny fraction of the total circulating supply. In the end, the system is highly reliable and efficient. After the banknotes are burned, tons of ash remain. Some companies repurpose this ash into materials for making compost or even bricks. This part fascinates me. Dollars get reborn and continue serving humanity in new ways. This is one of the most expensive and complex machines ever built by humankind. Constructing it costs more than $3 billion and takes over 7 years to complete. It can dive to depths of more than 3,000 feet, remain submerged for months without surfacing, and launch missiles capable of altering the course of war. But how exactly is a nuclear submarine? An engineering masterpiece that remains nearly invisible even to the most advanced radars, built. Right now, you are about to witness this incredible process. A nuclear submarine is a highly sophisticated engineering marvel, and its creation begins long before the first sheet of metal ever touches the manufacturing tools. The initial designs are developed using advanced computer modeling software. At this stage, several critical parameters are considered, including hull dimensions and shape, power systems, weaponry, and noise reduction technologies. The length can range from 300 to 550 feet, directly impacting the submarine's diving depth based on its class. The most advanced submarines can descend to depths of 2,000 or even 2,500 feet, while some experimental models can go beyond 3,000 feet. Based on these initial designs, physical models of the submarine are constructed and tested in water tunnels. This allows engineers to analyze how the hull shape affects maneuverability, water resistance, and noise levels. Meanwhile, computer simulations help predict the submarine's behavior underwater at different speeds and during various maneuvers. Once all simulations confirm the calculations, the blueprints are sent to production. This is where theory turns into practice. Building nuclear submarines requires special materials capable of withstanding extreme pressure at great depths while providing corrosion resistance. Typically, high-grade steel or titanium alloys are used. Steel is more cost-effective and easier to manufacture, as it can endure high pressure and impacts. Titanium, on the other hand, offers superior strength, corrosion resistance, and non-magnetic properties, which reduce the risk of detection. However, titanium is more challenging to process and weld, as its melting point is significantly higher, approximately 3,034 degrees Fahrenheit compared to steel's 2,500 degrees Fahrenheit. Before construction begins, all metal sheets undergo heat treatment, which involves heating, cooling, and applying special anti-corrosion coatings. The hull of a modern submarine is assembled from modular sections, simplifying the construction process. Metal sheets are cut with massive laser and plasma cutters, ensuring precision down to the millimeter. Each sheet is then shaped using hydraulic presses to achieve the desired curvature. Some parts of the hull feature spherical or cylindrical structures. The sections are assembled separately. These are massive rings, or compartments, that will be joined in the final stage. This modular approach allows different sections of the submarine to be worked on simultaneously, accelerating the overall construction timeline. Once all components are ready, the most critical phase begins: welding the hull. Welded seams must be exceptionally strong, as even a microscopic crack could lead to catastrophe at great depths. To meet all safety standards, automated electron beam welding is used, producing perfectly uniform seams. Additionally, every weld is inspected using ultrasonic scanners and X-rays. Most nuclear submarines feature a double hull design. The strong inner hull withstands deep sea pressure, while the outer hull provides a streamlined shape, improving hydrodynamics and reducing detectability. Ballast tanks are often located between these hulls, allowing for buoyancy control. To keep the submarine as stealthy as possible, anti-sonar coatings are applied. These include noise-dampening polymer tiles that absorb sound waves, microporous composite materials that minimize the submarine's acoustic signature, and noise-reducing coatings for the propellers and power systems. Once all sections are ready, they are connected. Gigantic cranes transport the compartments into specialized docks, where they are bolted and welded together. The completed hull is then tested for air tightness by filling it with compressed air and checking for leaks. A structural integrity test is also conducted in a hydrostatic pressure chamber, simulating real deep-sea conditions. Once the submarine's hull is assembled and its strength verified, it is time to install its most crucial component, the nuclear reactor. This is the heart of the submarine, allowing it to stay submerged for months, or in some cases, even years. A nuclear reactor is more than just a machine. It is an entire energy system consisting of various auxiliary components that occupy a significant portion of the submarine. Modern nuclear submarines use reactors that function by heating water to generate steam. The nuclear fuel, typically enriched uranium-235 or uranium-238, is placed inside the reactor's core. As nuclear reactions occur, heat is produced, which then heats water in a closed-loop system. The resulting steam drives turbines that generate electricity and power the propeller. The reactor is transported in protective containers and installed using cranes through a designated hatch on the upper part of the hull. It is placed within a specialized compartment in the submarine's core, surrounded by radiation-blocking materials. This compartment is also equipped with emergency cooling systems and reinforced safety barriers. The reactor is mounted on a shock-absorbing platform that minimizes vibrations and impacts during submarine movement. Next, heat exchangers and steam generators are installed to ensure efficient coolant circulation, followed by the installation of turbines and electric generators, critical components for the submarine's overall operation. Finally, the compartment is sealed with multi-layered lead and composite panels to minimize radiation exposure to the crew. To ensure functionality, an initial test ignition of the reactor is performed. During this test, power levels are gradually increased, radiation levels in all compartments are measured, and cooling systems are tested under maximum loads. With the reactor in place, the submarine is still far from operational. At this point, it consists of empty corridors and compartments. So the next step involves installing control systems, life support mechanisms, weaponry, and crew quarters. Sonar systems are mounted in the bow and along the hull, enabling the detection of enemy vessels and underwater terrain mapping. The onboard computer system and automated combat control stations are integrated, ensuring precise maneuvering capabilities. Weapon systems are also installed. Torpedo tubes are positioned at the front, equipped with automated reload mechanisms for rapid firing. Strategic submarines are fitted with missile launch silos located in the central hull. Each silo is equipped with hydraulic locks and pressure control systems, allowing for missile launches at extreme depths. Considering that the crew can remain submerged for months without surfacing, nuclear submarines must be self-sufficient. They are equipped with oxygen generators, carbon dioxide removal systems, heating and ventilation mechanisms, and water reserves. Ever seen those tiny capsule hotels? Well, submarines have something very similar: sleeping capsules. They also feature dining areas stocked with provisions and a command center filled with control panels, maps, and communication devices. After the living quarters are fully equipped, the submarine is almost ready for deployment. But the most thrilling phase remains: a series of rigorous tests to prove that it can withstand immense pressure, stay undetectable, maneuver in extreme conditions, and perform combat missions. These tests can last anywhere from 6 months to 2 years and include both factory trials and combat training for the crew. The submarine undergoes another airtightness test, followed by assessments of its electrical and navigation systems and a final reactor ignition. For the first time, the submarine leaves the shipyard and enters open waters. Stabilizers, hydraulic cylinders, and steering mechanisms are tested. Sharp turns, dives, emergency maneuvers, and maximum speed tests, typically 25 or 35 knots, are performed. The submarine then submerges to periscope depth, about 65 feet, to evaluate stability. At greater depths, ballast tanks are tested under load, and the submarine is gradually lowered to its maximum allowable depth, usually around 2,000 feet, depending on its class. Reactor performance under maximum load is also assessed. Once the submarine has proven its seaworthiness, combat systems are tested. Initial shots are fired using training torpedoes without warheads. Strategic submarines conduct the launch of a single ballistic missile, typically following a launch-dive airburst trajectory. Tactical submarines perform test launches of Tomahawk missiles or similar weapons. The submarine also enters an area with hydroacoustic sensors, where specialists measure noise levels at various speeds and evaluate the effectiveness of its sound-absorbing rubber coating. Finally, the submarine undergoes a simulated combat mission, during which the crew must demonstrate full operational readiness. What if I told you that every bottle you throw away could live an infinite number of lives? Ardagh Group creates more than 160 million packaging units each year, using thousands of tons of recycled glass. Now imagine the scale: industrial crushers that process up to 3 tons of glass per hour, and furnaces working at full capacity to give this material a new life. What does this grand transformation look like? Keep watching. You will be amazed. The company participates in various programs aimed at reducing landfill waste, actively collaborating with municipalities and other organizations to collect and recycle glass. Through these efforts, Ardagh increases the proportion of cullet used in production, as reusing glass is more energy efficient than making new glass from raw materials. For example, the company supports deposit packaging systems, where consumers return used glass bottles for recycling. They also work with waste sorting centers, providing equipment to clean and prepare cullet for processing. In many countries, Ardagh funds community education programs to raise awareness about the importance of recycling glass. Through these initiatives, Ardagh Group not only minimizes landfill waste, but also significantly reduces production energy costs, as glass made from cullet melts at lower temperatures. This is an essential part of their sustainability strategy, focused on conserving natural resources and reducing environmental impact. Each year, the company produces over 160 million packaging units, highlighting its scale and importance in the global market. Thanks to advanced technologies and high manufacturing standards, Ardagh Group remains an industry leader, contributing to economic development and environmental responsibility. The story of Ardagh Group began in 1932 in Dublin, Ireland, when the company started as a small glass packaging manufacturer. Its founders aimed to meet the growing demand for glass bottles, driven by the expanding food and beverage industries. In its early years, the company produced bottles for local breweries and dairy businesses, gradually increasing its scale. A pivotal moment came with the strategic decision to expand through acquisitions. In the 1990s, the company began acquiring plants specializing in glass containers across Europe and beyond. It later entered the metal packaging sector, diversifying its business and tapping into new markets. Today, Ardagh Group is a global leader in packaging production. Its growth story is one of transforming from a small regional manufacturer into a world-renowned corporation that remains committed to its mission, creating high-quality, sustainable packaging that meets the needs of the modern world. Ardagh Group embraced the use of recycled glass as part of its commitment to addressing contemporary environmental challenges and economic trends. Glass is an ideal material for reuse, as it can be recycled an infinite number of times without losing quality. Over time, the company realized that transitioning to more sustainable production practices was not only an ethical necessity, but also a powerful business strategy. Several factors influenced this decision. First, growing demand from customers seeking eco-friendly packaging. In a world where more people are concerned about climate change and pollution, glass containers made from recycled materials have become an attractive solution for many brands. Second, economic benefits. Using recycled glass reduces energy costs. Melting cullet requires 30% less energy than producing new glass. This, in turn, lowers carbon emissions. Thus, using recycled glass has become a key part of their business, supported by both environmental and economic advantages. Garbage trucks deliver collected glass to specialized recycling facilities. There, it is first inspected to sort out materials unsuitable for recycling, such as ceramics, plastic, or metal. Next, the glass is crushed into cullet, small pieces that are easier to melt and clean. This cullet is then transported to glass manufacturing plants, where it is used as raw material for producing new bottles, jars, or other glass containers. The glass arriving at the recycling plant is initially inspected and sorted. Automated systems or manual processes remove foreign materials, plastic, metal, paper, or ceramics, that could disrupt further processing. The company employs approximately 20,000 workers globally. Before crushing, the glass is washed. Powerful systems rinse away dirt, labels, and product residues. High-pressure water jets remove everything. Dried ketchup, wine remnants, stuck on labels, and even tiny bits of paper that seem impossible to clean off. This step is crucial for ensuring the purity of the raw material. Water streams splash everywhere as the glass passes through special brushes and rollers spinning at high speed, polishing each piece to a shine. The noise resembles a small waterfall storm. Watching clean, perfectly shiny glass emerge from the machines is a spectacle, transforming what was once dirty and labeled into something pristine. It feels like magic, but it is actually cutting-edge technology at its best. The cleaned glass moves into specialized crushers. There, it is ground into small particles using powerful mechanical hammers or rollers, resulting in fragments ranging from a few millimeters to several centimeters. This material, known as cullet, resembles gravel. Industrial hammer crushers can process up to 3 tons of material per hour. To remove any remaining foreign materials, the cullet passes through magnetic separators for metals and air jets for plastic and paper. Additionally, laser or optical scanners automatically sort the glass by color into clear, green, and amber categories. Sorting glass by color is not merely an aesthetic choice, but a critical technological process with several practical benefits. Colors affect the final quality and properties of the new product. For instance, clear glass is used for beverage or cosmetic bottles and must be kept as pure as possible. Green or amber glass, on the other hand, is ideal for packaging that protects contents from ultraviolet light, such as beer or wine. Color sorting is also essential for melting, as each glass type has unique temperature and chemical characteristics. Mixing colors can destabilize the process and risk producing defective batches. Mixed colors are harder to recycle. Such glass is often sent to lower priority uses or not reused at all, increasing waste. Properly sorted glass reduces energy consumption during recycling, as there is no need to clean the material of color impurities. Therefore, color sorting not only ensures the purity and quality of new glass, but also significantly reduces energy costs and maximizes the use of recycled resources. The finished cullet is stored in bins or bags and transported to glass manufacturing plants. Depending on the requirements, it is used as raw material for producing new glass. Though cullet appears sharp, storing it in bags is entirely feasible due to specialized materials. These bags, called big bags or flexible intermediate bulk container, are made of ultra-durable polypropylene with multiple layers that prevent tearing, even from sharp glass edges. Sometimes, the inner layer of big bags is additionally coated with laminated material for extra strength and dust resistance. The cullet, reduced to pieces ranging from a few millimeters to several centimeters, has edges that are less likely to puncture the bag material. Storing in such big bags is not only safe, but also highly convenient. The bags are easy to transport, stack, and dose for further use in furnaces. After preparation, the cullet is transported to Ardagh Group factories, where it is transformed into new glass products. A significant portion of the cullet is loaded onto trucks, either standard or specialized, depending on the volume and route. For larger shipments, even rail cars are used to cut transport costs and reduce the carbon footprint. Upon arrival at the factory, the cullet undergoes another inspection. This ensures that the material meets all requirements, such as the absence of any foreign impurities or pieces of the wrong color. Afterward, it is fed into melting furnaces, advancing the recycling process to the next level. Incidentally, the closer recycling plants are to manufacturing facilities, the more economically and environmentally efficient the entire chain operates. This is another reason why Ardagh Group actively supports local glass collection and recycling systems. Coca-Cola's annual sales exceed $47 billion, which translates to more than 1.9 billion bottles consumed every day. To meet this huge demand, the company operates over 900 bottling plants worldwide. But how exactly is this refreshing, fizzy drink made? To uncover the secret ingredient added to Coca-Cola, we will embark on a journey across the United States and dive into the atmosphere of one of Coca-Cola's massive production facilities in the country. The mysterious formula that defines Coca-Cola's flavor is carefully kept secret. Some say it is stored in one of the most secure vaults on the planet, and only a select few have access to this culinary secret. However, it is known that the drink contains a blend of natural flavors, including vanilla, cinnamon, and citrus. This precise combination of aromas gives Coca-Cola its signature taste, setting it apart from other sodas. The production of Coca-Cola is a detailed and complex process that ensures consistency and perfection in every bottle of this iconic drink. At the beginning of the process, the components are combined. A precise mixture of high fructose corn syrup, caramel coloring, caffeine, and phosphoric acid is blended in exact proportions to create a syrup with 50% sugar content. The syrup is then poured into massive mixing tanks, holding 5,000 gallons, where it is combined with water at a ratio of 1:5. At this stage, the mixture is continuously stirred to ensure the perfect integration of all ingredients. The next stage of the process is carbonation, where carbon dioxide is added to the mixture to create Coca-Cola's signature bubbles. This process is carefully controlled to ensure the same level of carbonation at all production facilities. To achieve this, the water is chilled to just above freezing, and carbon dioxide is pumped in under high pressure, allowing it to dissolve more quickly. Once the liquid has absorbed enough carbon dioxide, it is bottled and sealed tightly. When you pop open a fizzy Coca-Cola, the carbon dioxide under pressure is released, forming bubbles and creating the iconic fizz. Next, we enter the section dedicated to packaging the product. Here, plastic bottles are formed by blowing preforms into their final shape, before being filled with the carbonated mixture. At this stage, each bottle is carefully inspected by a machine to ensure that the amount of liquid is correct, and the caps are sealed properly. Bottles that do not meet the standards are removed from the production line. Speed and efficiency define the Coca-Cola bottling and capping process. As bottles are neatly placed onto a conveyor belt, they are then sealed and the product is labeled. Before distribution, each bottle is stamped with the production date and batch code, either on the cap or the side of the container, ensuring all necessary information is visible. The drink is also packaged in cans and glass containers, with multiple production lines operating simultaneously. Glass bottles are primarily reused, undergoing a thorough cleaning process using chemicals and high-pressure water, fully restoring them. However, brand new bottles are also produced. Coca-Cola follows a recycling strategy, continually encouraging the use of reusable packaging. Quality control is crucial in Coca-Cola's production process. The company implements strict measures to ensure that every bottle meets high-quality standards. Tests are conducted at various stages of production to guarantee the product's consistency and quality. These tests include tasting the mixture to verify its flavor, carbonation, and appearance. Additionally, bottles are tested under pressure to ensure they can withstand carbonation. Beyond these checks, Coca-Cola follows rigorous sanitation and safety procedures. To protect both workers and the product's integrity, employees wear protective clothing and ensure that the production facilities remain clean and free from contamination. The production of Coca-Cola is a complex and carefully controlled process that ensures consistency and quality in every package. After passing quality control, the products undergo a thorough wash with powerful jets of water before being packed for shipment. Cans and bottles are arranged into compact forms or stored in containers. With pinpoint accuracy, mechanical arms expertly position the blocks in place to create large pallets. The blocks are then moved to the packing area, where they are neatly arranged and carefully wrapped to ensure smooth transportation. The finished product is shipped to stores and distributors all over the world, making Coca-Cola available everywhere. The production process of Coca-Cola can vary slightly depending on the region, as customer preferences may differ. To cater to these preferences, Coca-Cola adjusts its recipe to align with local tastes, ensuring that every customer enjoys the flavor they love most. However, the core ingredients remain unchanged, carefully selected and blended to give the drink its signature taste. In the early stages of production, these elements are combined in precise proportions to create the liquid that gives Coca-Cola its unique and unmistakable flavor. High fructose corn syrup, derived from cornstarch, is used as a sweetener in many carbonated beverages. Coca-Cola's distinctive dark brown color comes from caramel coloring, which is achieved by heating sugar to the point of caramelization. Each year, more than 660 million pounds of sugar and other sweeteners are used to meet global demand for the beverage. Caffeine is included to give a boost of energy, while phosphoric acid adds a subtle tartness that balances the sweetness of the high fructose corn syrup. A crucial component of large-scale Coca-Cola production is water. Each processing plant requires a significant amount of water to meet production needs. In Mexico alone, Coca-Cola uses more than 14.5 billion gallons of water annually to maintain operations. The combination of these elements creates a delightful experience that has made Coca-Cola a legendary global drink. What actions do you think Coca-Cola has taken to reduce its environmental impact? Recently, Coca-Cola has been implementing innovative, plastic-free packaging alternatives to conserve resources and reduce waste. In 2023, the company introduced the Light Pack Top, an original holder made from recyclable cardboard designed to store bottles and cans. This replaced traditional plastic packaging and helped reduce the company's plastic use by 220 short tons per year. Coca-Cola is also committed to promoting the recycling of plastic and aluminum packaging. Recycling signs and information are placed on plastic containers and street bins to raise awareness about waste separation. At recycling plants, used plastic bottles are collected, inspected, sorted, and transformed into new products. A large industrial machine grinds the bottles into small pieces, which are then cleaned and go through a complex compression process, turning them into fresh plastic containers for food. Coca-Cola has recently updated its product lineup to include healthier and more eco-friendly alternatives, with a focus on low-sugar beverages and social responsibility initiatives. The company has launched environmental projects, such as optimizing water usage and creating recyclable packaging. Today, Coca-Cola is one of the most well-known brands globally, present in over 200 countries, and offering a diverse range of products that cater to a wide variety of consumer preferences. Did you know that a banana isn't actually a fruit from a tree, but rather a type of giant grass? And a single bunch can weigh up to 110 pounds? From tropical plantations to your table, join us as we uncover the amazing secrets behind the banana's journey and learn about the technologies that make it all possible. In the world of fruits, there is one true king, essential to breakfast, dessert, or any afternoon snack. This fruit is not only delicious, but also incredibly nutritious, with a history that goes back centuries. Yes, you guessed it, we are talking about bananas. But do you know where they come from and the journey they take from seedling to your plate? I traveled to the tropical regions where bananas are grown, ranging from Latin America to Southeast Asia. Each region has its own unique methods and traditions for cultivating these green treasures. Today, I'm excited to share with you the fascinating process behind it all. Sunrise on a banana plantation marks the start of another hardworking day. Here, among endless rows of greenery, begins the story of every banana that will eventually make its way to your table. Bananas aren't trees in the traditional sense of the word. They are the largest herbaceous plants, producing fruit in bunches that can weigh up to 110 pounds. Growing such a marvel of nature requires not only knowledge and experience, but also incredible care and attention. Caring for banana plants starts with planting seedlings and continues all the way through to harvest. Farmers regularly inspect the plants for pests and diseases, ensuring they receive the right amount of water and nutrients. Modern technology plays a key role in banana cultivation. From drip irrigation systems to drones used for monitoring plant health, these innovations help increase yields while reducing the environmental impact. It all begins in the fields, where the meticulous work of planting banana seedlings and preparing the soil takes place. I watched as farmers used cultivators to carefully place the seeds in the optimal spots and gently watered the seedlings with a fine mist or spray. The maturation period for banana plants can range from 9 to 20 months, although some varieties develop faster than others. As the plants mature, special agricultural techniques are applied. For instance, farmers trim the tip of the banana bud to stimulate the development of the bunch. To speed up the formation of banana clusters, they also remove some of the female flowers. Over time, these clusters grow into mature bananas. At this stage, disease management becomes crucial. Common banana leaf diseases, such as Xanthomonas wilt, Fusarium wilt, and black or yellow sigatoka, are combated by removing infected leaves and using pesticides. These treatments are essential to protect banana crops from pests and ensure a healthy harvest. Harvesting bananas is truly an art that requires precise timing based on visual cues, such as the size and ripeness of the banana. During this time, workers also monitor the growth of pups, young banana plants that sprout from the roots of older plants, to ensure they stay healthy. I watched as workers carefully cut each bunch from the vine, taking great care not to damage the fruit. Once the bananas are harvested, they are sent to processing areas. The bunches are tied together and transported via a conveyor system to a washing station. During the washing process, bananas are cleaned of harmful bacteria and debris to prepare them for further processing. For transport, they are protected by cotton paper, which is placed between each row of bananas to keep them safe during their journey. Bananas are highly perishable, so quick preparation is essential. When I arrived at the banana processing plant, I was shown the entire preparation process. First, the bananas are rinsed with water, measured, and the protective cotton paper is removed. Before they are packaged, the bananas are cut into smaller bunches and washed one last time to ensure they are completely clean. Workers then use scissors to cut the bunches into sections, check the weight, and prepare them for distribution before moving them to the packaging line. This precise procedure highlights the level of care and attention required to ensure bananas remain fresh and high quality throughout their journey from the field to the consumer. The transportation and storage of bananas is a complex process that requires close monitoring at every step. After harvest, the bananas are carefully packed into boxes to prevent damage. They are then transported in special temperature-controlled containers to avoid premature ripening. During transportation, often by sea, the bananas are kept at an optimal temperature of around 55 degrees Fahrenheit. Upon arrival at their destination, bananas go through a ripening process in specially equipped chambers. Here, the temperature and ethylene concentration are carefully controlled to ensure the bananas ripen evenly before they reach store shelves. This process allows the bananas to develop their characteristic yellow color and desired softness. In stores and markets, bananas are kept at room temperature, away from direct sunlight and ethylene-producing products to minimize further ripening and extend their shelf life. This helps ensure that the bananas remain fresh and flavorful until they reach the consumer. At the same time, there is a dedicated section of the factory for producing banana chips. Banana chips are a tasty and popular snack made by drying or frying thinly sliced pieces of banana. They can be made from either ripe or unripe bananas, depending on the desired flavor and texture. I watched as bananas were peeled by hand to remove the fruit. Banana chips, made from either mashed or sliced bananas, are fried in hot oil and turn out incredibly delicious. Once the chips are fully cooked, they are placed on a draining tray to remove excess oil, ensuring they have a perfectly crispy coating. The dried chips are seasoned with spices to make them even more flavorful. The factory staff carefully plan each step before sending the chips to the packaging area, which is managed by an artificial intelligence-powered machine. Before placing the chips into plastic bags, the machine takes precise weight measurements. Once the workers finish filling the bags, they place them into paper containers and seal them with the company's branding. These containers display important information, including the serial number, production date, and expiration date. The containers are then securely sealed with tape, ensuring the chips are safe for transport and storage. This comprehensive process, starting from banana cultivation and ending with banana chips and market-ready packaging, highlights the significant effort and technology involved in preparing these products for sale or export. It offers an interesting glimpse into the banana processing industry, showcasing the intricate procedures used to preserve the freshness and high quality of bananas from harvest to final sale. Banana chips are a source of nutrients like potassium, B vitamins, some dietary fiber, and minerals, especially when they are dried. However, fried banana chips can contain a considerable amount of fats and calories, so they should be eaten in moderation. You can also make banana chips at home, where you can control the amount of oil and seasoning added, making them a healthier option compared to store-bought varieties. The next time you grab a banana, take a moment to think about all the effort that went into its cultivation, harvest, and delivery. Remember that each bite connects you to distant countries, cultures, and people who make this world so vibrant and diverse. Did you know that over 20 million tons of peas are grown worldwide each year? This humble vegetable is not only incredibly beneficial for our health, but it also plays a key role in agriculture by improving soil and supporting ecosystems. Today, we are embarking on an exciting journey to uncover all the secrets of peas from the field to your table. You won't want to miss it. Peas are not only delicious, but also highly nutritious. Thanks to their unique ability to fix nitrogen from the atmosphere, peas enrich the soil, making it more fertile for future crops. To grow a good harvest, peas require specific conditions: plenty of sunlight, moderate rainfall, and well-drained soil. All of these are crucial for their growth. When summer arrives, it's harvest time. The process can be labor-intensive and may either be fully automated or require manual labor. especially when it comes to varieties of peas intended for fresh consumption. Depending on the size of the farmland and local traditions, different types of equipment are used to prepare the soil for planting peas. The planting process itself takes place in several stages. For peas to sprout and bloom, they need sufficient moisture, which is why seeders scatter the seeds across prepared beds. Irrigation methods depend on the type of soil, weather conditions, and water availability. Harvesting peas can be done by hand or through mechanization. On larger farms, combine harvesters are often used to speed up the process significantly. Specialized harvesting machines are equipped with pickup drums that gather the plants from the field and transport them to a threshing chamber. Inside this chamber, a rotating beater separates the peas from the plants. These mechanized harvesting systems can not only collect the peas but also clean them of leaves and stems right there in the field. After harvest, the peas are either sent directly for processing or go through additional cleaning and sorting. At the processing plant, the peas are placed into large receiving pits, where they undergo preliminary cleaning. From there, they are sent to a sorting line, where vibrating screens separate out any underdeveloped or damaged peas. Next, the peas are transferred to sizing machines, which sort them by size for further processing. The selected peas then move on to the washing stage, which involves several steps. An initial rinse to remove larger debris, followed by a thorough wash in tanks filled with water that is constantly filtered and refreshed to maintain cleanliness. After washing, the peas go through a blanching process, where they are briefly immersed in hot water. This step helps preserve their bright green color, retain nutrients, and improve texture. Blanching also eliminates any potential microorganisms. Afterward, the peas are rapidly cooled in cold water to halt the cooking process and maintain their freshness. Sorting is crucial to ensure only the best peas are selected. The washing process occurs on conveyor systems. First, the peas are rinsed to remove dirt, then they are submerged in specialized tanks for a more thorough cleaning. The water used for washing is often recycled and reused in the process. A crucial step for frozen peas is blanching. This process helps preserve their color, flavor, and nutritional value, while also killing bacteria and enzymes that could cause spoilage. After blanching, the peas are transferred to freezing chambers, where modern equipment rapidly lowers their temperature. This quick freezing prevents the formation of large ice crystals, helping to maintain the product's texture. Next, the peas are moved onto a conveyor belt for preservation. At this stage, they are placed into sterilized glass jars or metal cans. The peas are then covered with a hot solution made of water, salt, and sugar, which helps preserve their taste and texture over an extended period. After that, the jars or cans are sealed tightly and sent for sterilization, where they are exposed to high temperatures to eliminate any remaining microorganisms. This process ensures a long shelf life, without compromising the product's quality. Sterilization is one of the most crucial steps in the canning process. First, the jars containing the peas are heated to about 250 degrees Fahrenheit, which destroys harmful microorganisms and enzymes that could lead to spoilage. The sterilization process can last anywhere from 20 to 45 minutes, depending on the size of the jar and the density of the packing. Once sterilization is complete, the jars are quickly cooled to room temperature to prevent the glass from cracking due to thermal shock. This stage is essential for maintaining the integrity of the packaging and ensuring the product's quality. After sterilization, the peas go through a cooling phase to halt the heating process and avoid packaging ruptures caused by sudden temperature changes. Next, the canned goods move to the labeling line, where each can is marked with product information, expiration dates, and barcodes. To ensure transparency and ease of use, each can must include detailed information such as the production date, expiration date, and storage recommendations. This helps consumers feel confident about the quality and freshness of the product. After labeling, the cans are packed into cardboard boxes for transportation. At this stage, automated systems are used to place the cans in boxes with minimal manual handling, which speeds up the process and helps prevent damage. Once packaged, the cans are sent to a temporary storage warehouse before being distributed to retail locations. One of the final stages is quality control. Every step of the production process is closely monitored to ensure compliance with sanitary and technological standards. Specialized on-site laboratories regularly conduct tests to check the can's seal integrity, the presence of foreign particles, and organoleptic properties such as the taste, color, and smell of the peas. Only after passing all inspections is the product approved for shipment to the consumer. Smaller packages of peas are placed into cardboard boxes for further transportation. Automated systems and robotic arms tightly wrap each package in protective film and prepare it for shipment. Modern technology allows this entire process to be quick and efficient while maintaining high product quality. Special conveyor lines equipped with robotic manipulators carefully wrap each container in protective film, helping to prevent damage during transport and storage. Frozen and canned peas are shipped to supermarkets, stores, and markets. They are also used in the food industry to create ready-made meals. Logistics play a crucial role in maintaining the freshness of the peas. Frozen peas are transported in refrigerated trucks, while canned peas are shipped under conditions that prevent spoilage. For frozen peas, special refrigerated containers are used to maintain a constant temperature throughout the entire transportation process, which helps prevent spoilage and preserves their nutritional value. Canned peas are also transported with temperature control in mind to prevent packaging ruptures or the growth of microorganisms. Here are some interesting facts about peas. First, peas are one of the richest sources of plant-based protein among vegetables, making them an excellent choice for those who don't eat meat. 1 cup of fresh peas contains about 1/3 of an ounce of protein, which helps maintain muscle and overall health. Second fact, peas are high in fiber, which is essential for healthy digestion. Fiber promotes regular bowel movements and prevents constipation. Additionally, it supports the growth of beneficial bacteria in the gut, improving the microbiome and strengthening the immune system. Third fact, NASA has included peas in its list of plants suitable for growing in space. Their high nutritional value, ability to improve air quality through photosynthesis, and ease of cultivation make peas an ideal candidate for space missions, such as expeditions to Mars. Have you ever wondered how simple ingredients come together to create 100 tons of the legendary Nutella? We start with 20 tons of hazelnuts from Turkey, 15 tons of sugar, and 10 tons of cocoa from Ghana, transforming them into a flavor loved by millions. From the chocolate shortages during the war to millions of jars on store shelves today, are you ready to discover how the magic happens at each step? Let's dive in. Nutella was created in Italy during World War II when chocolate was in short supply. Confectioner Pietro Ferrero mixed hazelnuts with chocolate to create a more affordable product. Originally, his recipe was called pasta gianduja, but it was eventually transformed into Nutella, which was released in 1964. Today, this chocolate hazelnut delight is available to everyone, and I'm here to walk you through the entire process, from cocoa beans in Ghana to the finished product on store shelves. Let's start with an analysis of the production plans. Here are some numbers for you. If 100 tons of Nutella are planned for production, we need to calculate the required amount of ingredients. That means around 20 tons of hazelnuts, 15 tons of sugar, 10 tons of cocoa powder, 8 tons of palm oil, 5 tons of powdered milk, and 440 pounds of vanilla. The ordering process with our trusted suppliers begins, usually from Turkey, Africa, Malaysia, and our local farms. The purchase order is based on analytical forecasts, aiming to optimize the production process and maintain top-quality raw materials. For example, 20 tons of hazelnuts are ordered 2 months before production to ensure they are fresh. Next comes the logistics. Every detail must be carefully planned since the raw materials are sourced from different corners of the world. Hazelnuts are shipped from Turkey, cocoa powder comes from Ghana, and palm oil makes its way to our warehouses by sea from Malaysia, which means transportation can take about 4 to 6 weeks. Once the goods arrive, the raw materials are stored in dry, dark facilities with strict temperature controls kept between 59 and 68 degrees Fahrenheit to prevent spoilage and oxidation. Detailed record keeping of each batch is also essential, ensuring that we can trace their origins and meet food safety standards. This step is crucial for maintaining the high quality of the final product and adhering to environmental and ethical standards. Even though the hazelnuts are shipped in specialized containers to prevent damage, they undergo a thorough quality check before processing, just like the other ingredients. This involves using contactless sensors that measure moisture levels and temperature upon receipt. The moisture content must not exceed 8%. Additionally, a visual inspection is carried out using high-resolution cameras that detect defective nuts and any foreign particles. If defects are detected, the system automatically separates them. The hazelnuts are then cleaned in automated cleaning machines, with each batch handling 1 ton of hazelnuts at a time. The process takes around 30 minutes, during which air streams remove the skins and other light particles. Quality control is maintained through sensors that monitor airflow speed and adjust the intensity of the cleaning process in real time. The cleaned hazelnuts are then automatically transferred to roasting ovens. We set the temperature between 320 and 360 degrees Fahrenheit and wait for about 15 to 20 minutes. The ovens are equipped with automated thermal sensors that monitor temperature and humidity levels. If the humidity exceeds 1%, the system automatically adjusts the roasting parameters. After roasting, the hazelnuts are moved into cooling chambers, which ensure rapid cooling to room temperature between 68 and 77 degrees Fahrenheit. This cooling process takes approximately 30 minutes. The chambers are also equipped with sensors to maintain consistent temperatures for even cooling. Next, the hazelnuts go into automated grinding machines with a capacity of up to 2 tons at a time. The grinding process takes about 10 to 15 minutes. These machines are equipped with control systems that ensure the desired paste consistency is achieved. The key objective is to reach a 50% oil content, which is essential for achieving a smooth texture. Do you smell that? I call it the scent of magic, when a few simple ingredients transform into a flavor everyone knows. Now, we're moving on to the mixing process, so let's take a closer look at how it all happens. In large mixers with a capacity of up to 30 tons, all the ingredients are loaded in. These mixers come equipped with automatic speed controllers, allowing the blade rotation speed to be adjusted based on the consistency of the mixture. We set the speed to 60 revolutions per minute and wait about 20 to 30 minutes for the process to finish. During mixing, it's crucial to monitor the temperature, as it affects the final texture of the product. The mixers are equipped with temperature sensors that automatically adjust cooling if the temperature exceeds 86 degrees Fahrenheit. Workers receive real-time temperature data, allowing for quick adjustments whenever needed. An essential process we'll discuss now is emulsification. Emulsifiers in Nutella play a key role in ensuring a smooth texture, preserving flavor, and extending the product's shelf life. For emulsification, an automated system is used for precise dosing of emulsifiers, which typically make up about 1 to 2% of the total mixture. A common choice is soy lecithin. The system ensures accuracy up to 0.1%, which is critical for the stability of the final product. The prepared mixture is then loaded into automated emulsifiers with a capacity of up to 30 tons. The emulsifier is equipped with paddle stirrers that can operate at speeds of up to 1,000 revolutions per minute, enabling rapid and efficient mixing. It's crucial to monitor the temperature of the mixture, which should not exceed 105 degrees Fahrenheit to prevent oil breakdown and preserve flavor. To maintain this, the emulsifier is equipped with thermostats. If the temperature starts to rise, the system automatically activates cooling elements, keeping the conditions optimal. During emulsification, workers monitor the viscosity of the mixture using automated sensors. The ideal viscosity for Nutella is about 20 to 30 Pascal seconds. If the viscosity is too high or too low, the system automatically adjusts the mixing speed or adds oil to achieve the desired consistency. After the emulsification process is complete, about 30 tons of finished mixture is produced, with a temperature of around 105 degrees Fahrenheit. This temperature helps maintain the uniformity and texture of the emulsion. The finished mixture is automatically pumped into cooling tanks. The system has a capacity of around 265 gallons per minute, allowing for rapid processing of large volumes. The cooling tanks are equipped with automated cooling systems that can bring the temperature down to 68 degrees Fahrenheit within 30 to 40 minutes. Temperature is monitored in real time, using sensors to maintain stability throughout the entire process. During the cooling stage, the moisture content of the emulsion is also carefully monitored. The ideal moisture level should not exceed 5%. If the humidity is higher than the standard, the system automatically activates dehydrators to remove excess moisture. This step is crucial for ensuring a longer shelf life for the product. The finished Nutella is automatically pumped into filling machines using pumps with a capacity of up to 265 gallons per minute. The filling machines automatically portion the Nutella into jars with a volume of 14 ounces. Each jar weighs about 1 pound, including the packaging. The system ensures accurate filling with a tolerance of up to 1%, achieved through automated scales that weigh each jar during the filling process. After filling, the jars pass through an automated capping machine. It uses airtight lids to ensure long-term freshness, and the machine can cap up to 600 jars per hour, enabling the efficient processing of large volumes. Next, the jars are labeled using an automated labeling machine, which can label up to 500 jars per minute. Before starting the process, it's essential to check that the label hopper is stocked with enough labels. Each label includes information about the product, ingredients, expiration date, and barcode. Labels are applied with an accuracy of 0.02 inches, thanks to sensors that monitor the position of the jars on the conveyor belt. The system automatically checks for proper label placement and detects any defects, such as misalignment or missing labels. If the system identifies an issue, it automatically halts the machine, preventing errors in production. After labeling, the jars are automatically transferred to the packing machine. Here, they are arranged into cardboard boxes, with 12 jars per box. The packing process operates at a speed of up to 300 boxes per hour. The boxes are formed automatically without the use of glue, utilizing specialized mechanisms that ensure both speed and reliability. During packing, the system monitors the proper arrangement of jars within each box. If a box is missing jars, or if they are incorrectly placed, the system triggers an error alert. Each box is equipped with internal dividers to prevent damage to the jars during transportation. The finished boxes are then automatically fed onto a conveyor where they are stacked onto pallets, typically with about 100 boxes per pallet. Each pallet is labeled with information about its contents, making subsequent storage and transportation easier to manage. After the packing process is complete, the quantity of finished Nutella pallets is checked, usually around 200 pallets per day, with each pallet holding 100 boxes containing jars of Nutella, each with a volume of 14 ounces. An automated warehouse management system generates routes for forklifts, which transport the pallets throughout the warehouse. In the loading zone, specialized hydraulic lifts come into play, automatically raising pallets to the height of the truck's cargo area. Typically, a single truck can hold up to 30 pallets. Each truck is provided with automatically generated labels that include information about the contents, production date, expiration date, and final destination. The trucks then head out to distribution centers located up to 500 miles from the plant. The transportation status is monitored through a GPS system, allowing real-time tracking of each vehicle's location. When a truck arrives at the distribution center, the pallets are scanned again to confirm receipt, and they're then prepped for their next journey to supermarkets and into the hands of eager customers. Imagine if every glass bottle you throw away could become the key to saving the planet, and even earn you some extra cash. Did you know that over 130 million tons of glass are recycled worldwide each year? I recently visited one of the largest recycling plants to uncover the fascinating secrets of how ordinary glass takes an incredible journey from the trash bin to new possibilities, transforming our lives along the way. So, how does a glass item get a new life? The recycling process for bottles begins with collecting used glass. In many cities and countries, a system of separate waste collection is in place. which greatly helps with efficient recycling. Special containers for glass collection are set up in various locations, separated from those for plastic, paper, and organic waste. This prevents glass from mixing with other materials, making the recycling process smoother. In some countries or companies, glass collection points have been established, where people can return used bottles and receive a reward in exchange. This encourages the public to participate in gathering and returning glass bottles for recycling. In many former Soviet Union countries, the collection of glass is often carried out by vulnerable and marginalized groups. However, in European Union countries, it is a routine practice for everyone to return used containers, often receiving something like a discount on their grocery bill in return. Once collected, the glass is sent to recycling plants, where the main processing begins. Once the glass bottles are collected from containers or drop-off points, they are transported to specialized sorting centers for further processing. Waste collection trucks periodically pick up the glass from these containers and deliver it either to sorting centers or directly to recycling plants. This is typically done on a large scale to make transportation more efficient. At the plants or sorting stations, the trucks unload the glass bottles into large containers, where they begin the preparation process for sorting and recycling. Once the bottles arrive at the facility, the next step begins, sorting the glass by type and color. This step is crucial to optimizing the recycling process. Sorting glass by color is extremely important because different glass colors are used for different products, and mixing them can reduce the quality of new items. The bottles are sorted automatically using special optical scanners that detect the glass color and sort it into clear, green, and brown categories. This is crucial since each type of glass requires separate recycling processes. These sorting machines are equipped with sensors that identify the color of the glass using light sensors. Whole bottles or glass fragments move along a conveyor belt, where machines illuminate them with a lamp or laser. The light reflected from the glass is analyzed by the sensors. The system identifies the glass color based on the signal received and sends this information to a controller. After identifying the color, each glass piece is directed to the appropriate section, either through a stream of air or mechanically removed from the conveyor. The glass is then separated into different streams, which significantly simplifies the next steps of melting and reuse in new products. Once sorted by color, the glass passes through magnets and air streams to remove metal elements like bottle caps, as well as other impurities such as paper labels or plastic residues. Powerful magnets are placed along the conveyor belt to capture all metallic impurities, including steel caps, while electromagnetic separators are used to remove aluminum caps and foil pieces. Pneumatic systems are used to blow away plastic and label remnants from the conveyor, using strong air currents to clear away any materials that are not needed for further recycling. Of course, the glass also undergoes a wet cleaning process in special washing systems, as many of these bottles will be reused to make containers for food products. Just think about it. We discard bottles without a second thought, not realizing how much effort goes into recycling them. Compared to other materials, glass does not wear out or degrade with use, making it an incredibly sustainable material for continuous recycling. After the sorting process, the glass is crushed into what's called cullet, which serves as the raw material for making new glass products. Specialized machines are used to break down glass bottles into small pieces, making further processing easier. These crushers come in various types, but most work using a mill with two parts, one stationary and one movable, where the glass is ground down as the two parts rub against each other. Crushers can include jaw, cone, roll, hammer, and gyratory types. The glass is fed into the crushing machine via a hopper or conveyor belt, and inside, mechanical elements reduce it to the desired size. Some crushers go through multiple stages of crushing to ensure uniform particle size. At this point, any remaining impurities that were not removed during sorting can be further filtered out. After crushing, the cullet is sifted to remove pieces that are either too large or too small. This is done to ensure a uniform mixture of cullet that's ready for melting. From this finely crushed cullet, new bottles and jars are most often produced. It can be a bit unsettling to think that something made from waste ends up as new tableware, right? But the powerful processing and extremely high temperatures used in recycling leave no chance for the glass to carry any trace of its former life into the finished product. After being crushed, the cullet undergoes further cleaning to remove any remaining contaminants and is treated before heading to the melting furnaces, starting with magnetic separation. This process eliminates any leftover metals that may have passed through the sorting phase. It's crucial because even small traces of metal can disrupt the glass melting process. Next, specialized technologies are used to remove any organic residues, such as paper labels, adhesives, or other materials, ensuring that the cullet is completely clean before melting begins. The glass fragments are then sent to vibrating sieve machines, where they pass through screens of various sizes to separate the cullet into different grades based on particle size. Different grain sizes are used for different glass products. At this stage, the entire process is automated, with machines equipped with monitoring and control systems. The use of specialized machinery also reduces the risk of injury for workers handling glass bottles, as the entire process takes place in a controlled and safe environment. After being cleaned, cullet is sent to recycling plants, where it is transformed into new molten glass. At the plant, the cullet is loaded into special furnaces, where it melts at temperatures ranging from 2,800 to 3,000 degrees Fahrenheit. The glass becomes liquid and ready to be shaped into new products. Adding cullet to the melting process reduces energy consumption, as recycled glass melts at a lower temperature than raw materials. Occasionally, new raw materials such as sand, soda ash, and limestone are added to the melting process to maintain the chemical composition and quality of the glass. This helps ensure the strength and clarity of the new products. Once the glass is transformed into a molten state, it is used to produce new glass items. The liquid glass is poured into molds to create various products such as new glass bottles, jars, vases, or other containers. Lower quality recycled glass is often used as filler in concrete, which enhances its aesthetic appeal, increases strength, and improves thermal insulation. In large factories, this process is fully automated and may involve high-precision molds to ensure the desired quality and thickness of the glass. After shaping, the glass products pass through specialized cooling systems, where the temperature is gradually reduced. This step is crucial to prevent cracking and ensure the mechanical strength of the finished products. After forming, the new glass products undergo rigorous quality control to ensure they meet safety and durability standards. Optical and mechanical tests are conducted for this purpose. Specialized systems inspect the products for defects such as air bubbles, cracks, or improper shapes. If a product does not meet the required standards, it is sent back for recycling. Additionally, the items are tested for mechanical strength, especially in the case of glass bottles, which must withstand pressure and other stresses during use. Once all stages are complete, the new glass products are packaged and transported to the market for further use. In large factories, the packaging process is also automated. Glass products are grouped and packed into cardboard boxes or placed on pallets for easy transportation. The finished goods are then shipped to warehouses or directly to customers, such as beverage, food, and other product manufacturers, where they will be used again, allowing the glass recycling cycle to start anew. This process is both economically and environmentally beneficial. Glass recycling plays a significant role in reducing greenhouse gas emissions and water pollutants. By using recycled glass material to produce jars and containers, we can minimize waste and lower our carbon footprint. Additionally, producing glass from raw materials requires extraction methods that negatively impact the environment, making recycling a much more sustainable choice. Glass recycling offers significant environmental benefits due to its energy efficiency. Using recycled glass, cullet, helps reduce energy consumption in the production of new products, as melting cullet requires lower temperatures than melting raw materials. Researchers in this field have noted that energy use can be reduced by 3%. Recycling also decreases the amount of waste sent to landfills. Since glass does not naturally decompose and can remain in the environment for thousands of years, recycling it is crucial for environmental preservation. Additionally, glass recycling conserves natural resources. By recycling glass, we reduce the need for raw materials like sand, soda ash, and limestone, helping to preserve these resources for future generations. Have you ever wondered how the microchips that power modern technology and artificial intelligence are made? No, they don't fall from the sky or grow like mushrooms in the forest. They are the result of incredibly complex processes that demand extreme precision and automation. Let's dive into the world where pure silicon becomes the brains of our devices and discover just how much effort goes into making it possible for you to ask an artificial intelligence, "How do I talk to a girl?" The primary material used to manufacture chips is pure silicon. The choice of this material is no coincidence. Silicon has semiconductor properties that allow it to efficiently conduct electric current under certain conditions, which is essential for creating microchips. But silicon crystals don't just appear out of thin air, they are grown. Like mushrooms, can you imagine? Specialized companies are responsible for growing silicon, providing the semiconductor materials needed to produce microchips. The main suppliers are Japanese, Taiwanese, German, and American companies. Silicon monocrystals are formed using the Czochralski method, where silicon is melted and then gradually cooled to form a large cylindrical ingot. In a high-temperature furnace, a seed crystal, also called a seed, is slowly pulled from the molten silicon while rotating. This ingot is then sliced into thin silicon wafers, usually between 200 and 300 microns thick. These silicon wafers are polished to a perfect smoothness and cleaned of any contaminants to prevent defects in the future microchips. This is done using special chemical solutions and mechanical procedures. Next, chip designers create the architecture, which includes millions of transistors, logic gates, and other components necessary to perform artificial intelligence tasks. This is an incredibly complex process, requiring a high level of specialization and the use of automated design software. First, they design the chip's architecture, the structure and layout of all the components. The architecture of an artificial intelligence chip may include graphics processing units, neural network processors, and specialized computing blocks designed for high-efficiency matrix operations. During the design verification phase, computer simulations are used to test and validate the design. This allows for the identification and correction of errors before moving on to physical production. The next stage in chip production is called photolithography. Photolithography is a crucial technology for manufacturing microchips, involving the creation of the pattern for future electrical circuits on a silicon wafer using light. This is one of the most critical steps because it determines the precision and density of the components on the chip. A specialized robotic machine, equipped with tweezers to avoid direct contact and prevent contamination, handles the silicon wafer. The machine then immerses the wafer in chemical baths with cleaning solutions to remove any dust particles, oils, or other impurities. Afterward, the wafer is placed on a machine that spins it at high speeds to evenly distribute a layer of light-sensitive material across its surface. It's similar to placing the wafer on a fast-spinning disc and dropping liquid on top, allowing the material to spread out through the spinning motion. To apply the pattern onto the wafer, a process called light exposure is used. A machine, similar to a large projector, uses a photomask, essentially a template that allows light to pass through in specific areas. This projector directs ultraviolet light through the photomask, and the light reaches the photoresist only in certain spots. It's like using a stencil for painting, where the paint only goes through the cutout areas. After exposure, the wafer is again immersed in a chemical solution, but this time to develop the image. The solution dissolves the parts of the photoresist that were exposed to the light, or the parts that were not, depending on the type of photoresist. Think of it as developing a photograph, where the details of the pattern emerge in the chemical bath. Once the image is developed, the wafer moves to another machine for the etching process. This is similar to carving and is called etching. The machine either sprays gas plasma onto the wafer, dry etching, or immerses it in a chemical solution, wet etching, to remove the unwanted material, leaving only the necessary parts behind. In the final stage, the wafer is cleaned again to remove any remaining photoresist. Machines immerse the wafer in chemical solutions or use special laser technologies to ensure it's thoroughly cleaned. Can you imagine how much micro-level work goes into all of this, just so my friends can ask artificial intelligence how to approach a girl? Or, get this, I overheard some girls asking ChatGPT to do tarot card readings for them. So, here we have people and machines working hard, meticulously developing technologies, and then someone's like, pull a card of the day for me. Admit it, do you get asked to do that kind of crazy stuff often? Anyway, let's continue. After the remaining photoresist is removed, the silicon wafer undergoes a visual inspection using microscopes, but it's all done by automated systems, robots and cameras scanning for even the tiniest defects to ensure everything is flawless. At every stage, nearly everything is handled by automated machines, because even the smallest mistake or speck of dust can damage the microchips. Humans mainly monitor the process, adjusting machine settings and troubleshooting if any issues arise. To create regions on the wafer with different electrical properties, a process called ion implantation is used. This involves introducing impurities into the silicon. Ions of a specific material are accelerated and embedded into the silicon wafer, altering its semiconductor characteristics. After implantation, the wafer undergoes a process called annealing, heating the wafer to activate the ions and restore the crystal structure of the silicon. Next, layers of metal, typically aluminum or copper, are applied to form electrical connections between the transistors and other components of the chip. After manufacturing is complete, each chip undergoes a thorough inspection for defects and a series of tests to confirm its performance. The testing includes checks for functionality, speed, heat resistance, and energy consumption. Chips that do not meet quality standards are either discarded or recycled. This process ensures that only products fully meeting all technical specifications are retained. Packaging chips is the final stage of production, where the finished chips are prepared for use in electronic devices. This process is also primarily carried out by automated machines. First, the silicon wafer, which contains hundreds or even thousands of chips, needs to be cut into individual chips. A special laser machine, or a precision diamond cutter, is used to slice the wafer into separate tiny chips. This process is called dicing. Once the wafer is cut, each chip is attached to a substrate, base, which helps connect it to the rest of the electronics. An automatic die attach machine picks up each chip and precisely places it on the substrate, using a special adhesive or other material to secure it in place. For the chip to interact with other components, it needs to be connected to the substrate with very thin wires. This is done using a wire bonding machine, which welds fine gold or aluminum wires that link the chip to the contacts on the substrate. After the chips are connected, they must be protected from mechanical damage, dust, moisture, and other harmful elements. To achieve this, the chips are enclosed in protective casings. An automatic chip packaging machine covers the chip with a special plastic or epoxy resin. This process involves encapsulating the chip in a protective material, creating a durable casing around it. After testing, the chips are marked with information such as the model, serial number, and other relevant data. This is done using laser marking machines, which quickly and accurately apply all necessary information to the surface of the chip's casing. Once testing and marking are complete, the chips are packed into anti-static boxes or specialized plastic tapes for easy transportation. Automated packing machines organize the chips in rows, package them in special containers, and prepare them for shipment to customers. The chips are inspected to ensure they meet all standards and are ready for transport. This process is overseen by logistics personnel and automated systems, which manage the warehouse, sort the products, and handle shipping to clients. Did you know that over 10 million cakes are produced worldwide every day, with ingredients traveling from every corner of the globe? In this video, we'll dive into the fascinating world of massive conveyor belts and fully automated production lines, where simple ingredients are transformed into sweet masterpieces in just minutes. Get ready to uncover the industry secrets you never knew existed. Cake factories in the United States and worldwide purchase ingredients in volumes that match the scale of their production. They typically sign contracts with large ingredient suppliers, such as producers of flour, sugar, butter, eggs, dairy products, and flavorings. These suppliers can deliver consistent, large-scale shipments and often adhere to strict quality standards, which is crucial for maintaining the taste and quality of the final product. Core ingredients like wheat flour are usually bought from large manufacturers or cooperatives, while specialized ingredients like flavorings or colorings may be sourced from specialty companies. Logistics companies deliver these products directly to factories, often in refrigerated or sealed containers to keep everything fresh. Some ingredients like chocolate or exotic fruits are imported from producing countries, chocolate from Latin America for instance, since this can offer better quality or pricing compared to local sources. Imagine that the ingredients in your dessert might have traveled from nearly every part of the world. Modern cake production is fully automated, with ingredients added to the mixer via conveyor systems and dispensers, requiring no human intervention. For instance, dry and liquid ingredients are added using dosing and weighing systems. Each ingredient comes from its own container, fed through automated pipes or funnels that accurately measure and deliver the required amount into a large industrial mixer. Flour, salt, and sugar are dispensed from bins or containers through piping systems. They pass through dispensers that precisely control weight and quantity before being moved on a conveyor to the mixer. Butter, milk, water, and eggs are fed through special pump systems that control liquid flow, connected to dispensers that automatically add the exact amount of liquid ingredients into the mixer. At large factories, eggs are often used in the form of pasteurized liquid egg mixtures, stored in refrigerated containers. When whole eggs are needed, they are automatically cracked by special machines, with the shells separated, leaving just the egg mass for mixing. All these ingredients are then combined in the large mixer for blending. After mixing, the batter is directed to specialized dosing and filling machines that precisely measure and dispense it into baking molds. The batter from the mixer travels through a conveyor or pumping system to the dosing station. A holding tank or container is used to store the batter temporarily for convenience until the next step. Pumping equipment regulates the batter flow to ensure smooth, continuous transfer. At this stage, the dispenser carefully measures the batter volume that will be distributed into the molds. Dosing mechanisms are set to provide each mold with the exact amount of batter, which is crucial for achieving consistent cake sizes. Some systems use volumetric dosing, which measures batter by volume, or weight-based dosing to ensure the precise weight of each product. An automatic filling head distributes the batter into pre-arranged molds on a conveyor. As the molds move under the dosing head, the filling mechanism releases the required amount of batter directly into each one. These molds may be round or rectangular, depending on the product type. To avoid overfilling or underfilling, dispensers are equipped with a feedback system that adjusts batter amounts based on weight or volume data. Some filling machines have sensors that monitor filling levels and automatically stop once the correct amount of batter is reached. After the batter is poured into molds, the conveyor moves them into specialized industrial ovens. In large-scale production, tunnel ovens are used, where the conveyor with molds passes continuously from one side to the other. The baking temperature and time are carefully calibrated for each type of batter. These ovens are preheated to specific temperatures, typically ranging from 302 to 356 degrees Fahrenheit for cakes. The ovens maintain a steady temperature and control humidity levels, with modern models equipped with automatic temperature control systems to ensure even baking. It's crucial to maintain consistent heat distribution and optimal moisture levels during baking. Industrial ovens are often equipped with steam injection or ventilation systems to manage humidity, helping to create the perfect crust and texture for the cakes. The conveyor moves at a speed that allows each product to bake for the optimal amount of time, typically 20 to 30 minutes. Tunnel ovens feature adjustable temperature zones, so the batter rises at the beginning of baking and achieves an even color and texture by the end. This automated process allows for the simultaneous baking of thousands of cakes. After baking, the conveyor moves the molds with freshly baked cakes onto a cooling line, where they rest to stabilize their temperature. This step is crucial to prevent deformation and ensure perfect texture. Cooling usually happens via fans that blow cool air over the cakes. As soon as the cakes exit the oven, the conveyor transfers them onto a designated cooling line. At this stage, the cakes are still very hot, so gradual cooling is essential to prevent cracking. On the cooling line, fans or air conditioning systems blow cool air evenly over the cakes. The fans operate at multiple levels to cool the cakes uniformly from all sides, avoiding sudden temperature changes. I have to say, after my air conditioner broke this summer, I could have really used a tour like this to escape those 2 weeks without cool air. Some factories use spiral coolers, which are conveyors coiled in a spiral, allowing cakes to move upward and cool gradually along the way. This design saves space and provides ample time for gradual cooling, perfect for high-volume production. To prevent excessive drying, the cooling areas maintain an optimal humidity level. Some cooling systems even allow humidity adjustment to prevent the cake surfaces from drying out and to keep them looking fresh and appealing. Once the cakes are cooled, they move along the line where they are prepared for filling. All the necessary ingredients for the cream, such as buttercream, ganache, or other types of fillings, are pre-prepared and stored in large barrels or tanks. Automatic pump systems allow the cream to be transported directly from the tanks to the application area. This shortens the processing time and reduces the risk of contamination. The pumps maintain the required pressure so that the cream flows smoothly to the filling machines. The cakes are then lifted onto a special conveyor with a mechanism that has small fingers to gently hold each cake in place. Automatic machines apply the cream on the top of each cake, typically using sprayers or nozzles that distribute the cream evenly over the surface. If the cake has multiple layers, the mechanism automatically separates the cake into layers, applying cream between each one. This process also happens via conveyors that move each layer to the cream applicator and then return it to its original position. Fascinating, isn't it? After filling, the cake proceeds to the assembly stage. Here, special systems pick up each layer one at a time and stack them in the correct order. The machines may use different mechanisms, such as tongs, suction devices, or other technologies, to assemble the cake precisely without damaging it. Now comes the most exciting part, decorating the finished cakes. This is the stage that almost makes my mouth water, as it's nearly impossible to stay calm watching such artistry in action. After assembly, the cakes move to the decorating line. All the necessary materials, such as creams, glazes, fruit fillings, and other decorations, are prepared in advance and stored under controlled conditions. The cakes travel on a conveyor to a machine that automatically applies the glaze. This can be done using sprayers or injectors that form an even layer of glaze over the cake's surface. Next, a decorative pattern may be applied to the cake. This is achieved with special sprayers that create intricate designs using cream or glaze. Stencils or specialized machines may also be used to create embossed patterns automatically. Various decorative elements can be added to the cakes, including berries, nuts, chocolate pieces, sugar flowers, and other embellishments. Automated systems or robotic arms can carefully place these decorations, ensuring they're evenly distributed for a visually pleasing effect. During this stage, final touches like sprinkles of chocolate shavings, powdered sugar, or other toppings can also be added. Once decoration is complete, the finished cakes are transferred to an automated packaging line. Here they may be packed into boxes, wrapped in protective film, or otherwise prepared for transport.